Good day, guys. So in this particular video, we are going to be talking about partial fractions. So if we are talking about partial fraction, we have to understand some basics. The first is that when fractions are added together, they produce a single fraction. But this single fraction can be simplified back to its genesis. And this simplified fraction is called partial fractions. All what we've explained here, let's use this example for better understanding. So we said that when two fractions are added together, they produce a single fraction like this. They produce a single fraction. We said that if we should add these two fractions together, we are going to get these single fractions. So this single fraction can be simplified back. That is to say, we can break it back to its genesis. When we talk about this genesis, that is what? Is basic form. Is two general form. So it can be simplified back to its genesis. And this simplified fraction is what we refer to as what? Partial fraction. So that is why I said this is a single fraction, but these are the what? Partial fraction. So we can say that these are the partial fraction of this. So this simply means that this must equals to this. So in partial fraction, the single fraction must be the same as the what? As its partial fraction. So by now you should have been able to differentiate between partial fraction and what? Single fraction. So that is that. So guys, we have the forms of partial fraction. We have various forms of partial fraction, but we will be dealing with four out of the forms. The first one is linear denominator form. The second one is denominator not simplified. The third one is repeated denominator form, and the fourth one is improper fraction. So in this particular video, we are going to be solving partial fraction using the normal long step and the trick. So stay tuned. Now let's move on to the first one, linear denominator form. So guys, the first form of partial fraction we'll be looking into is the linear denominator form. You see, what you have to understand is that whenever you want to solve a particular partial fraction question, then you must firstly consider the form in which that question is. And after you've considered that, then you must be able to identify the general form of that particular question. So that is why if you want to be using the long method in solving partial fraction questions, then you must be very well acquainted with the what? With the general forms of what? Of partial fraction. So the first form we'll be talking about is linear denominator. This takes the general form of ax plus b all over x minus d, x plus f. So this simply means that whenever you have a partial fraction question in this form, you can easily split this form of partial fraction into this. It will just turn to a over the first thing here plus b over the second thing here. So let's look at a particular example in solving this. The example we have here is that resolve x plus 7 over x squared minus 7x plus 10 into partial fraction. Before I'm going to attempt this question, I will firstly check this question that, okay, this particular question, which forms of partial fraction is it taking? Is it taking the linear denominator form? Is it taking the improper fraction? So you will see that this particular question we have here is taking this linear denominator form. Someone will ask me that, how is this form taking this form? The reason why is this. You know the denominator here is x squared minus 7x plus 10, right? So if I should factorize this equation, I'm going to get x minus 2 x plus 5. If I should factorize this equation, this denominator, I'm going to get this. So this simply means that the question that I have, which is x plus 7 over x squared minus 7x plus 10. This can be rewritten as x plus 7 all over x minus 2 x plus 5. Then what does it showing? You will now see that this is now showing this general form we have here. That is to say, linear denominator form. Then we are now going to proceed with the solution for this. So therefore, this simply means that I will just say that this, which is x plus 7 all over x minus 2 x plus 5, it can be rewritten as this form: a over x minus 2 plus b over x plus 5. So it will be a over the first thing here plus b over the second thing here. So this is the form of what? Of re-expressing this type of equation. So whenever you have a denominator like this, in which you can easily factorize to get the factor like this, then those type of partial fraction question can be solved using this method. So let's continue with the solution here. Okay, guys. So guys, before we continue, please, this should be x minus 2, x minus 5, x minus 2, x minus 5, x minus 2, x minus 5. So it should be x minus 2, x minus 5. If we should factorize this, we are going to get x minus 2, x minus 5. Now, guys, let's continue. So the next thing we are now going to do here now is that we are going to look for a way to get the value of our a and the value of b. How are you going to do that? What we are going to do is that we will just say multiply both sides by x minus 2 x plus 5. So guys, I'm going to multiply both sides of the equation by what? X minus 2 x minus 5. I'm going to multiply through by this denominator x minus 2 x minus 5. So guys, if I should multiply these parts, if I should multiply it by x minus 2 x minus 5, this simply means that this x minus 2 x minus 5 is going to cancel this. Then I'm going to be left with x plus 7 equals. Also, if I should multiply this a over x minus 2 by x minus 2 x minus 5, sorry, x minus 2 x minus 5, this should be x minus 2 x minus 5. If I should multiply this by x minus 2 x minus 5, I'm going to be left with a x minus 5 plus, if I should multiply this by x minus 2 x minus 5, I'll be left with b x minus 2. So what's how this was equals to this after multiplying with this is this. You know, if I have something like a over x minus 2 and I multiply it by x minus 2 x minus 5, you know, this x minus 2 we just cancel with this x minus 2, then to be left with what? A x minus 5. So that was how this turned to this after this has been multiplied by this. So once I've gotten this, guys, I will now get the value of my a and the value of my b. Now, how am I going to get the value of a? How am I going to get the value of b? Guys, if I want to get the value of a, what I'm going to do is that I will if I want to get the value of a, I am going to eliminate b. And also, if I want to get the value of b, I am going to eliminate a. And whenever I want to eliminate b, I'm going to let the value of this, I'm going to equate this value of b, which is x minus 2, I'm going to equate it to 0. Also, if I want to eliminate a, I'm going to equate this value x minus 5 to 0. So let's do that, guys. To get a, to get the value of a, eliminate b. I'm going to eliminate this b. I will then say to eliminate b equates x minus 2 to 0. Therefore, x is equals to 2. So this minus 2, we cut to that side. So x is equals to 2. So therefore, substitute and substitute. So if I should substitute x is equals to 2 into this expression, I'm going to get it as 2 plus 7 is equals to A, 2 minus 5 plus B, 2 minus 2. 2 plus 7 is 9 is equals to A. 2 minus 5 is minus 3. Minus 3A. And 2 minus 2 is 0. 0 times B is 0. So therefore, my A would be equals to minus 3. And also, to get B, eliminate A. And to eliminate A, equate x minus 5 to 0. X minus 5 to 0. Then x is equals to 5. And substitute. So if I substitute this x is equals to 5 into this equation, I'm going to get it as 5 plus 7 is equals to A, 5 minus 5 plus B, 5 minus 2. 5 minus 5 is 0. So this will be 12 is equals to 3B. And our B is equals to 4. So this simply means that A is equals to minus 3, B is equals to 4. So my final answer will now be that I'm going to substitute the value of A and the value of B into this. And that's the final answer. So guys, after we've gotten the value of our A to be minus 3 and the value of our B to be 4. So therefore, we just say that the equation, which was rewritten as this, since the value of A is minus 3, so this will be equal to minus 3 over this, and the value of B is what? 4 over this. And this expression can be re-expressed or can be written as 4 over x minus 5 minus 3 over x minus 2. So therefore, this is the final answer. This or this is the final answer. So this simply means that this is the single fraction, this is the partial fraction. So the last thing we are going to do in this video now is that I'm going to show you how you can use option testing in what? In getting the value of your what? Of your answer for a partial fraction question like this. So guys, we are going to be solving this question using the trick method. If you have a CBT question or OBJ question like this, where they say we solve this into partial fraction, option A, option B, option C, option D, the trick is that let x equal 0. We're going to let x equal 0. So we firstly you first represent your x as 0 in the question. Then if I represent this x as 0 in the question, then the question returns to 7 over 10. So you will not go to the options one after the other. You'll be representing the x as 0. Anyone that gives you 7 over 10 is the correct answer. If I should represent the option A as, if I should represent this x as 0, I'm going to get option A to be 23 over 10. If I should do for option B, I'm going to get minus 7 over 10. If I should do for option C, I'm going to get minus 23 over 10. And if I should do for option D, I'm going to get 7 over 10. So according to what I got, this simply means that option A is wrong, option B is wrong, option C is wrong, option D is correct. So that is how to use the trick in solving the question when we are doing CBT or OBJ exam. So thank you for watching. In our next video, we are going to be talking about the denominator not simplified form of a what? Partial fraction. See you in the next video. Don't forget to like, comment, and what? Subscribe to this YouTube channel. Thank you.